Hi everyone, so now let's continue the following questions, which is question 4b. Okay, so for the electric flux through a paraboloid, okay, that lies below plane z equals to 0. So it is oriented by an outward unique normal vector with the f given. Okay, so this one is about finding the flux, okay, coming out from the paraboloid. Okay, coming out from the paraboloid. Okay, so first of all, let us jot down the important informations. So for question 4b, yes, we have a paraboloid. Okay, paraboloid. So what is the equation of the paraboloid? Z equals to x squared plus y squared minus 16. Okay, minus 16. Okay, lies below plane z equals to 0. Lines below plane z equals to 0. Okay, outward. So outward unique vector. So just drop down outward, and the f is this. So you have a 3x, 4y, and negative 5z squared. Okay, so in order to find the electric flux through the paraboloid, so we have to use the surface integral, right? The surface integral. So what is the equation? So we have a double integral, okay, and this one. Am I right? Okay, we have to use this one, okay, for the surface integral. Okay, so if you look at this one, okay, we need to identify what is the n, okay, and what's the shape, what is the shape, because later on we need to define the dA. Okay, so maybe first of all we look at the n first. Okay, this is a unique normal vector. If it is outward, okay, the equation will be this one. Okay, then we have okay, so what is our f here? Okay, so our f here is paraboloid. So the equation for paraboloid is equals to x squared plus y squared negative 60. Okay, so fx will be 2x, fy will be 2y. Okay, so you can replace it. It will become negative 2x, negative 2y, and 1. Okay, divide fx squared plus fy squared plus 1. Okay, so we have complete the n. Now it's the dx. Okay, so the dx will become the dA, right? So the dA means that you need to look at the whole structures. Okay, you need to look at the whole structure and decide the projections. So this is a paraboloid. So this paraboloid has equations x squared plus y squared minus negative 16. So when the x and also the y, they are 0. This is the x, this is the y. When they are all 0, okay, so the value of the z will be negative 16. Negative 16, so this one will be the point. So since this is below the z equals to 0, so we will have a paraboloid like this. Okay, something like this. Okay, so this is the paraboloid. So if you refer to the dA, okay, it means that this is the xy projections. You will see the circles here. Okay, the circles here. So basically, it will be a round shape. Okay, so the equations, oh no, the radius of this circle will be, okay, if you want to know the radius, you could replace the z with 0. Okay, and you will see that the radius of the circle will be equals to 4. Okay, so the df will be written as the r, dr, and d theta, where the dr will be from 0 to 4, d theta will be from 0 to 2 pi. Okay, 0 to 2 pi. Okay, so now we can put it into our functions. We have a double integrals. Let me see the f. The f is equals to 3x 4y minus 5z squared. And I dot product with my n, okay. Negative 2x, negative 2y plus 1. And then the dA is the r, dr, and d theta. Okay? Right. So now, the range of the r is from 0 to 4 and 0 to 2 pi for the d theta. So let us solve this thing. Okay, so let us simplify again by replacing the z, okay, with the equation of the paraboloid. So this will be x squared plus y squared minus 16 and square, right, r, dr, and d theta. Okay, continue transformations into the r and d theta. All right, what we can do, okay, here is still negative 2y squared minus 5x squared okay, so this one could become r squared. Okay, y squared can become r sine theta squared, and this one can become r squared. Okay, so in fact this one I break into negative 6y squared, negative 2y squared. So this one I can factor it together with this one. Okay, I can factor this thing, these two together. Okay, so let's negative 6r squared minus 2r squared minus 5 r squared minus 16, and we have a square r dr d theta. Maybe you want to multiply the r into it. Okay, so I can take the r inside, so become 5r. This one become r power 3, and this one become r power 3 as well. Okay, now you can use a calculator. Okay, negative 384. Okay, this is for the first one, negative 384. And for the second one, you have an integrate negative 2 square. Okay, 4 and 0. No, square, sorry. Cube. Negative 128 sine square theta minus integrate Okay, so maybe this part and this part we can combine. This one we press sine x is equals to pi okay. Okay, so this one is answer. Okay, so this is the flux coming out from the surface of the paraboloid. Okay. Right, so now we move on to the next questions. That is the question C. Determine the flux of the vector field across a cone that lies in between the plane z equals to 4, okay, and z equals to 8 by using the Gauss theorem. Okay, by using the Gauss theorems. So let's see how we can solve this thing. First of all, let's jot down the important informations. 4C. So we have the F. Okay. So you have a cone. And it is in between 4 and 8 plane. Okay, so you have to use the Gauss theorem. So this question very similar to the previous question, is finding the flux from the surface of cone. Okay, but it's asking you to use the Gauss theorem. Okay, so Gauss theorem is telling us that Gauss theorem is also divergence theorems. Okay, we can find the flux coming out from the surface by using triple integral. Then you have a divergence of F, and here it will be dV. Okay, here will be dV. So the first thing that you must solve will be the divergence of F. So the divergence of F, okay, let's solve together. Okay. Dot product with the F. Okay, the F is x power 3 negative 2y and 7z. Okay, so we differentiate with respect to the x, we get 3x squared. Okay, negative 2 and plus 14z. Okay, so this one will be the equations. Okay, so the z over here you can replace. Okay, so the z over here you can replace with the equations of the cone. Okay, equation of the cone. So it will become 3x squared plus negative 2 plus 14. The equation of the cone is x squared plus y squared square root plus 3. Okay. So we can plus 14 plus 14 right. So this is the divergence of F. Okay, so now we need to define the dV. Okay, dV is a volume, so you need to look at the volume of this cone. Okay, we draw this cone. Okay, so this cone is something like this. Okay, is 3. Okay, right. And then the question mentioned is in between 4 to 8, right? Plane. Okay, so 4 might be here. Okay, 8 will be here. Okay, so this is 4. Okay, so it means this part. Okay, so the dV, we have to choose the coordinate system to use. Okay, so we could use the cylindrical. Okay, cylindrical. Okay, so the dz will be from 4 to 8. Am I right? 4 to 8 because it's a horizontal plane. Okay, and for the dr, d theta, you need to have a projection view. Okay, so for this, you will see 2 circles. One is at the top when the z is 8, and small one is at the bottom when the z is 4. Okay, you need to find out what is their radius. Okay, what is their radius? So you can use these equations. This is the equations of a cone when at position 8. Okay, so here will be 8 minus 3. So it will become 5 square. Okay, so the radius is 5. Okay, Whereas at the position 4, so you will have a radius of 1. Okay, so this also means that your dr will be from 1 to 5. Okay, d theta will be from 0 to 2 pi because both are complete circle. So now we put them here. 0 to 2 pi is the d theta, and then 1 to 5 as the dr, and 4 to 8 as the height. So internally we have this. Okay, 3x squared plus 4t plus 14. Okay, x squared plus y squared. Okay, so we are going to solve using the cylindrical. Wait, just now I simplified the z, right? I think I cannot simplify the z. Okay, so I cannot simplify the z, otherwise I cannot integrate it. Okay, so I think just ignore this one, okay, and also this one. Okay, so I will take this. Okay, because I need to integrate it. If I simplify, I cannot integrate. So it will be 3x squared minus 2 plus 14z. Okay, so let's do the integration with respect to the z. Integration with respect to the z. So here will become 3x squared minus 2, and then you have the z. Okay, and this one is 14 z squared over 2, and you have the 8 and 4. Okay, so r, dr, and d theta. Okay, so you have a 3x squared minus 2. This is 8 minus 4. 8 minus 4 will be 4. Plus 64 minus 16. Okay, so the x here, you have to replace with the r cos theta. Okay, so let's replace with the r cos theta. R squared cos squared theta minus 2 and 64 minus 16, 48, r dr d theta. Okay, so you need to perform the integrations. So I integrate for r bracket. Oh no, you have the cos square, so you have to multiply them inside. So expand it again. You cannot press calculator, so have to expand again. So you will have, let me multiply it. So you have 12 r cubed cos square theta minus 8r, okay, plus 48. Okay, now you can press calculator. Integrate 12 cube 5, 1. So here you will have 1872 cos squared theta minus 96 and plus this one is 48 multiply 4, so 192 d theta. And integrate cos x square 2 pi and 0 is equal to pi. So this is equal to pi. So plus 192 pi. Okay, so the answer is 193 pi. Okay, 193 pi. Okay, 193 pi. Am I right? Oh, I forget this one, right? 1872 plus 1872. So it's 2064 pi. Okay. Alright, so this is the answer. If I have mistake, please let me know. Okay. Alright, thank you.